All right, everyone, welcome back for your second day of Chapter 4, Lesson 2. Now, my iPad was acting up, so I do have to record from my computer today, meaning that I won't be able to mark the text. So I want you to sit back and listen and think about things that you would mark, like circling those key words, underlining those key phrases, and then you can go back and look at the key on Canvas to help you fill in anything you may have missed on your own. So I'm going to start with page 129 where it says build a prototype. Now remember, you want to number your paragraphs. Build a prototype. After considering constraints and trade-offs, engineers build and test a prototype. A prototype is a working model used to test a design. Some prototypes may be full-size and made of materials proposed for the final product. Others are completely virtual or computer-generated. Prototypes are used to... Sorry, I lost my spot. Prototypes are used to test the operation of a product. Prototypes test how well the product works, how long it lasts, and how safe it is to use. A design team may have some people use the prototype and evaluate it. Engineers may also test the prototype in a lab to see how it works, as shown in Figure 5, or they may use computers to test virtual models. Test results help determine how well the product meets the goals and what improvements are still needed. So, some things I would underline in paragraph 1 are, after considering constraints and trade-offs, engineers build and test a prototype. I would also circle the word prototype and underline that it's a working model used to test a design. In the second paragraph, I would underline that prototypes are used to test the operation of a product. I'd also underline how well the product works, how long it lasts, and how safe it is to use. Finally, I'd go down to the bottom of the paragraph and underline where it says, test results help determine how well the product meets the goals and what improvements are still needed. So let's take a look at Figure 5. It says, build a prototype. Label each picture with the appropriate design step. On the notebook paper, describe the best way to test a prototype of a mouse. Explain why this method works. So, we're either going to write build a prototype or test a prototype above the pictures. So the first one has a picture of the mouse and I can see some tools and some different parts. So is that going to be build a prototype or test a prototype? Right, that's definitely going to be build a prototype. And in the second picture, he's thinking, oh, this doesn't slip at all, and he's actually using the prototype. You're right, so that's going to be testing a prototype. Now, on our notepad, we're going to write the best way to test a prototype of a mouse, or the best place to do it. So in our reading, it told us exactly where they were testing this mouse. Right, they're testing it in a lab, and that would be best. What are some reasons testing it in a lab might be the best option? I think one of the reasons I think it's the best option is you can use a lot of different tools to see how the mouse reacts to different problems. If you need to pause the video to finish writing in your answers, now is a good time. All right, let's look at page 131 or 130. I'm going to scroll down so I can see the paragraphs. Remember to number your paragraphs before you start reading. Troubleshoot and redesign. Prototype tests may uncover design problems. For example, tests may show that people have difficulty using a product or that a part breaks easily. The cause of any problems must be identified and the product must be redesigned. The process of analyzing a design problem and finding a way to fix it is called troubleshooting. In Figure 6, you can see a problem with the mouse that prototype tests revealed. The mouse was noisy. Troubleshooting identified the rolling ball is the cause of the noise. The engineers replaced the steel ball with a rubber ball to make the mouse quieter. Engineers also added an easy-to-open ring-shaped cap. This redesign also made the mouse easy to clean. Mouse technology progressed even further after these problems were solved. A wireless optical mouse uses a laser instead of a ball and can have a sensor instead of a wire connected to the computer. So, the first thing we're going to do is label our pictures. We are either going to label them as troubleshoot or redesign. So up here, they're thinking, that steel ball squeaks. Is there a mouse in here? It even looks like a mouse. So is this the troubleshooting or the redesigning portion? Right, this is going to be troubleshoot. So you're going to write troubleshoot up here in the box. In this picture, it looks like he's using tools to make some changes. What part of the process is this? Right, this is going to be the redesign portion. So for number 2, it says troubleshoot. Write in the table the problems with the mouse that caused the optical mouse to be invented. So what were the 2 problems that they addressed in the comic? Or in our reading? Right. Part of the problem was the ball was too noisy. So in the box you can write ball was too noisy. What else is wrong with the old mouse that we had to fix? Right, it has a wire, so it had to be connected to the computer. So you can write had to be connected to the computer in that bottom box. So how did they redesign it to make it better? To fix the problem with the ball, they got rid of the ball, so there's no ball anymore. And how did they fix the problem with the wire? They used sensors to make it a wireless mouse. Nice job. Finally, for the challenge, it says, why is it wise to provide time and money to redesign a problem or redesign a product? Right, so the redesign process can solve problems and make the end product better. If you need to pause, you can to finish filling in the answers. Let's move on to page 131, our last page for today. It says, communicate the solution. The last stage of the technology design process is communicating the solution. Engineers must explain the design to manufacturers who will produce the product. The engineers must describe their product to advertisers. In doing so, they must also communicate how a product meets the consumer's needs. Look at Figure 7 to see some of the ways engineers communicate. Frequently, inventors or companies will obtain patents to protect their inventions. A patent is a legal document issued by a government that gives the inventor exclusive rights to make, use, or sell the invention over a certain period of time. If others want to use the invention, they must obtain the patent owner's permission and pay a fee. After the patent's time runs out, however, anyone can make or sell the invention. All right, so if I were to underline some important spots, I'd want to remember that the last stage of the technology design process is communicating the solution. I also want to underline that they must explain the design to manufacturers who will produce the product. I also want to remember that they have to describe their product to advertisers. And they need to communicate how a product meets the consumer's needs. And finally, I want to remember this key word down here, patent. So I would circle that and underline that it's a legal document issued by government that gives the inventor exclusive rights to make, use, or sell the invention over a certain period of time. The last thing you need to do with your reading today is fill in the X assessing your understanding. So first you're going to explain what are design constraints, and then you're going to infer what steps would engineers take if there was a problem with an optical mice. Finally, under Got It, I want you to write down the steps to the technology design process. You can check your answers for this part and all parts of our reading by going to your Canvas page and checking the answer key. I will see you guys later. Have a great day.